Okay, this is day 5 of Swift. If you want to see Swift UI's day 5, check it out. It should be up by now. So for today, functions. Finally, we get into the real nitty gritty, everything I've been hearing about lately instead of just loops, conditions, creating variables and constants. Now it's functions. So when it comes to functions, from what I can understand, it helps us stop writing redundant code because when you think about it, when you're first starting off how to write code, you're basically just solving it just to solve it. You're not thinking about how can I refactor it, make it smaller, cleaner, more readable. I'm just trying to get the solution. So it might look like a whole bunch of redundancies, constant for loops, constant variables made. But if you know how to create something where you could just do it once and call it everywhere, I think that's where functions come into play, which is why the print statement is used out a lot. So like imagine if we had to constantly do the calculations just to print out whatever we wanted to print out. They was like, nah, let's just create a function called print and it prints out whatever they put into the parentheses, right? So for example, I created my own function and I just had it print out this text. Simple like that. Now, parameters, something we unconsciously know and do a lot when it comes to the code base. So like when I first started doing it, I just basically just put in a string, integer, double, boolean, and then it will just spit it out, right? But parameters help you change the behavior of the variables you put into it or the computations, right? So for example, I wanted to calculate the power level for a certain character, right? So I would set the parameters to two integers, basically doing the base power and the multiplier. So in Dragon Ball Z, they have certain power levels, and when you go Super Saiyan, it's multiplied. So that's why I have the multiplier and like the base power. But within that function, I'm not only telling it to print, but I also want them to do some calculations into it. And then when I call the function again, it'll print out the computation that's inside this logic. So rather than me constantly creating a variable outside and then just keep typing, I'm doing one function and then I could keep calling it. So I could call it again, and then just do 1000 or whatever, and then it'll keep doing the calculation because I keep calling it. So I can customize this function and then it'll calculate different data for any character that I have for this function. Now, returning values is a very important thing, especially when it comes to coding, because we don't want to just print out the results. We want the results returned to us because it's like they said in the beginning, the print statement is just for the coders when we're trying to debug or just look at what the logic is, right? But when you return something, you're able to actually use that value for other logic in the code base, right? So you would use the arrow and then give it like a return value. So it has to be some sort of value, right? And then you could do whatever calculation you set here. So I wanted to calculate the battle points out of my parameters, give it a type, and then did the calculations. And then afterwards, once when I call it, it gives me back a number, and then I'm storing that value into my new variable. So when I print this out, it should say, let's go here, it should say exactly. Naruto's battle points is this. Something bonus I learned is like if I wanted to get more than one value, tuples is what I would use this for. So for example, if I wanted to calculate the battle points and the rank, I would not only have to set the parameters, but also return tuple, like a tuple data set, right? So I did points, rank, made it a string, made it an integer, did the calculations, then obviously I did a ternary, however you say it, so that way I could store the value for the rank since it's a string. So if the battle points are higher than 1,000 or 10,000, give it S, else A, and then after that I want you to return me the tuple. I don't want to return anything else because that's what I asked it to return. And then now I'm getting the results. So I create a variable called results, and then I'm calling the function again and then just putting in the values. So this now holds a tuple. It's not gonna hold the results for the points, but actually just the numbers themselves, like the computation. And then now it should print out, dang, I hate when it does that. See, the battle points and what rank she is. Also, fun fact or hot take, I think Sakura has a better underdog story compared to Sasuke and Naruto. If you want to argue with me in the comments, do so. And then now what else? Okay, so I found out when it comes to parameters, there's two types of names that the computer notices. So the first name is for what we see. The second name is for the inside of the function. So that's what we use to do the calculations with. And then this is what can be seen on the outside when you're calling it. Now, the reason why they have this is so that way it makes it look cleaner and it just makes sense and is easier to read. So for example, I did greet master of master string, and then I'm printing out basically the master's name. And then once when I call it again, it doesn't show master anymore. It just shows of, because that's the name we're dealing with on the outside. Master is what we're dealing with on the inside. Now, if you don't want the name to come up, kind of like how if I scroll up here, the print statement, it's just empty, you have to use an underscore. And when you use an underscore, it'll just come up as blank, but then you could also still write it out there, but we tend to have parameters with names so that way it's easier to read and understand what that function does. So here I did perform move, I give it the name move with the string, character string, then I'm printing out the character's name and the type of move that it does. So perform the move Gohan, Masenko, then it should print out this print statement on line 89. But ideally, we want to have names for the parameters so that way we know exactly what it does, because there's going to be times where you have a function with the same name, but it does different things. So having the parameters with like multiple names or whatever, it makes it easier for coders to understand, oh, this is what this function does, even though it has the same name. Oh, and it's like I said before, when you're coding, it's not just for you, it's for people that is gonna debug your code, look through it. So you have to make sure when you're naming this type of stuff, it makes sense. Now, Veridic functions, what can I say about that, right? What I can say is that it takes in multiple parameters of the same type. So kind of like, for example, how the print statement, it could take in multiple strings as we're typing it up. All you need is just a comma, and that's because that's whoever created that print statement made it that way, right? So I did my own, and I did calculate total power level, I did levels, and then I just did a range of ints, so it could be any range I want, depending on the input I put it in when I call it. So this is just regular calculations, we all know that. But then as soon as I call it, I could do 1, 2, 3, 4, infinite numbers of parameters. And the reason why this is good is because one of the flexibility, it allows you to handle any arbitrary numbers of inputs, which is like what I did. So it could be from like 1 to 100, but ideally it's probably gonna be maybe 5 max, I think, but correct me if I'm wrong. Also, like the convenience, you could pass as many values as you want instead of like changing the function every time. So I did it this way, so that way I don't have to create another function just to do 2, then 3, then 4. Throwing functions. Now this one, it was pretty hard, I'm not gonna lie, right? Because understanding the concept of throwing when it came to function, it was just so, it went over my head a few times, right? But that basically means when somebody inputs something wrong, or when there's an error when the application is being used, we want to catch those mistakes, we want to catch those errors, so that way it doesn't crash on who's ever using the application, right? So I created an enum to help me catch the errors that might come along for this function. Because right now I'm trying to check to see whether or not if this ninja is going to enter in an easy passcode to get into the village, right? So I'm creating a function called check secret code. I did the underscore so that way it doesn't have to, give it a name. I did code, the string, and then I'm throwing some sort of error, and then I'm getting a Boolean because I want to see whether or not if it's true or not. So are they actually giving me an easy password or not? So if the code, like the string, is equal to 1234, I want you to throw it to the error enum so that way I can catch it and do some computations with that, because we don't want people to make mistakes like this, and we just want to catch it as soon as possible. So that's why on top of that, they want you to do something with the error that you've catched, which is why they have something like do, try, and catch, the thing I keep saying. So do this stuff if you think there's an error that might occur. So I'm calling the function here. So the person put in 2234. So it should be good. It should let into this spot. But if it was to say, then it's going to skip this, go here, and then print out code is too easy, try a different one. Else, I think this is kind of like we're just covering all of our bases here, right? Because I doubt it's going to come to this line, since this is the only case we have where it's like, oh, it's too easy, And then in and out, what can I say? In and out parameters. So from what I understood in the in and out parameters, it allows me to take a variable from the outside, put it in there, and make changes to it. Because from what I gathered, you aren't able to change the parameters values when you put into it when you call it, right? Because they're lets in that sense. Because when you're calling the function at that time, it can't be changed. But when you have the and symbol, it lets them know, or the computer know, that hey, you want to change this value in the computation itself. So you have to have this keyword in and out, and then this and symbol when you're calling it. So that way, this variable can actually change when you're calling it. So for example, let me just print it out. So notice how it was 50 at first. I did the and symbol. Now it's 100 on the side.